All right, well, we're gonna go ahead and get started. Welcome. My name is Peter Boverett. I'm the director of the Integrated Innovation Institute, where you are. I'm glad you're here. All of us are here, I think, because we have pretty strong beliefs and a lot of potential in Internet of Things, using a small device and getting older. So need some help here. When we think about the impact of digital, in the digital world, of course, has transformed everything. And if you go back years before that, when it was at the outset and a few people were sending emails because there was this thing called the internet, it's hard to imagine that anybody had the foresight to understand where it was all headed. It was a new capability, the interaction, but now in hindsight, wow, and it keeps on going. And here, it feels like, just maybe, we're at a similar outset of the blend of the interaction of digital and physical worlds, where digital is communicating through devices, making things happen in the physical world is sensing, giving information back to digital. And certainly there's been a lot of benefits that have already come out of Internet of Things. A lot of benefits have mainly, I would say, been the easy ones, to do better what we're already doing. Cost cutting. So this might be tracking assets. Those assets might be trucks. Those assets might be hospital tools, hospital hardware, where losing one is expensive on either case. So a lot of cost savings. Or let's look at manufacturing process and machines. Downtime's expensive. So let's make sure we don't have any downtime. Cost cutting. But really that's doing what we're already doing. But outset is all the new things. The new things that are new value, ways that services, products, conveniences that we haven't even dreamed of. And I think that's kind of what we're still grappling towards. I know, some examples, for me personally, one of my examples is a doorbell. I have one of these internet-enabled video doorbells, and it's really nice. So a few weeks ago, I was on the other side of the world, and somebody rang my doorbell here in Pennsylvania. I answered, and they had a question. They said the power company had removed a tree in my front yard, which I wasn't sure had happened, and could they haul off all the wood for me? Oh yes, that's a win-win. Yes, please take all of it. And you know what? That man probably didn't even know I wasn't home. That's impressive. So the safety, the security, convenience, that's new value. Who would have thought that that was a doorbell? I remember asking a question in a class a few years ago to my students of, your refrigerator can talk to you, but who would want the refrigerator to talk to them, and what would it say? But we're starting to see what it would say that's meaningful. I mean, there's emerging technologies to where when you're putting an apple or a cantaloupe in your refrigerator, that it'll know, it'll recognize that's an apple, that's a cantaloupe, and date stamp it, time stamp it when you put it in. Now you've got inventory management. You know you have an apple or a cantaloupe, so when you're at the grocery store, you don't need another one of those. But also it can tell you, hey, you need to use that apple before it goes bad. So food waste reduction. Inventory management, food waste. Now, yeah, I do want my refrigerator to talk to me to make life a lot more convenient. Who knows what other capabilities are upcoming? CMU is a really fitting location to have this kind of symposium. We think of the technologies that are developed at CMU. Sensors, great stuff happens here. Local computing, because you get that information, what do you do with information? How do you process it? Cloud computing, fog computing. I'm not even sure what the latest labels are. It's cool stuff, happens here at CMU. Mechanical devices, mechatronics, robotics, all these things happen here at CMU, but those are all technologies to create these capabilities. Here in this building, what our program is about is creating value, new value, things that the world needs, understanding what the world needs, and bringing together these technologies, capabilities, design, business, and engineering. That's what we're about. IoT is a new frontier. You're here, we're here. It's a great place to be. So welcome. It'll be fun to see where we go today. I'm going to actually have Dara come up to introduce our first speaker.
Thanks, Peter. I'm just going to get through a couple of logistics first. So I'm Dara Byrne. Most of you will have hopefully spoken to me or gotten an email off me about this event, so hopefully you all know me. If not, I'd love to talk a little bit more today. Some logistics. There's coffee in the back, which hopefully everyone has discovered. Please feel free to help yourself. We always get the question of where the facilities are. They're in the kind of the back on the right if anyone needs to use the restroom. There's also a second location up the stairs and things like that. And if you haven't already, please make your selections for lunch. We're going to move over at 11:45 to the Carnegie Cafe for a 2-course meal there. They're going to expedite everything by making sure selections are done ahead of time. So just let the folks down the back know if you haven't already. So with the logistics out of the way, I wanted to kind of speak a little bit about the symposium and a little bit about Zach as well. So we've organized this symposium because we've been thinking about the Internet of Things and preparing students to engage in solving problems in the market through our curriculum for the past 4 years, nearly 5 at this point as well. We're starting to think about what's next. In preparing our curriculum 5 years ago, a lot has changed in the market. And we're hoping that you will engage us a little bit in this dialogue about where things are going, what's happening next, and how do we prepare people to be elite innovators in this field. As part of the dialogue that we're trying to build, I can't think of anyone better to kind of kick us off than Zach from Particle. About 5 years ago, when we were starting to think about how we teach IoT here, I was searching for kind of a better way to prototype IoT devices. And that's when I stumbled on Particle, or then Spark, and their first microcontroller, the Core. And that was the first platform that we used as part of the instructional experience here. And we've continued to use it to this day. It's pretty awesome. As platforms go, they really blended circuits, code, and cloud components in a very, very elegant way. And Particle has become a great partner for us here in supporting that kind of educational experience. But more than that, over the past few years, they've moved IoT programming from something that people think about to something that anyone can and does now engage in. They've supported hobbyists, startups, and enterprises alike in making the Internet of Things and the devices that people imagine a reality today. They've supported countless products moving into the market as well. And they're just about to release their new version of the platform, Particle Mesh, later this summer as well. All that's to say that Particle has a mountain of experience of designing IoT devices in the wild and of thinking about what's on the horizon. And that's really why I'm excited they could be here today to kickstart our conversation about IoT today and tomorrow. So to formally introduce Zach, Zach is the founder and CEO of Particle, the most widely used IoT platform, making it easier to build, connect, and manage internet-connected hardware products deployed at massive scale. Particle was listed as Fast Company's most innovative companies in 2015 and is used by over 150,000 developers in more than 100 countries by half of Fortune 500 companies to develop and manage fleets of new IoT products. Zach is an authority on the Internet of Things, has spoken at a bunch of prominent events like OSCON, Solid, Web Summit, GMIC, and Launch. And without further ado, I'll let Zach take it from here. Please welcome Zach.
Well, thank you for the warm intro, and good morning, everyone. So I'm Zach. As was introduced, I'm the CEO of Particle. Started an Internet of Things company 6 years ago now, which makes it a relatively young company in the world, but a relatively old company in this industry, which given how young it is. If you want to check us out, particle.io, and I'm ZS on Twitter. Before I jump in, I would just love a quick show of hands of if how many of you in the room would describe yourselves as an IoT practitioner? All right, cool. So a mix. So some of the stuff I'll talk about may be old news to some of you in the audience. Hopefully not too much of it. But I want to start with the sort of thesis of this presentation, which is who's familiar with the Gartner hype cycle? So basically, the new technologies, after they're introduced, go through a peak of inflated expectations where people get really excited about the tech, and then people realize that maybe something's not quite there yet, the market isn't ready for it, so things come down into the trough of disillusionment, then climb the slope of enlightenment and reach the plateau of productivity. And Gartner likes to map technologies onto this and say where they are at any given time. And my perspective is, unfortunately, IoT is right here, right now, which is downward slope. We're coming off of the peak of inflated expectations. And that creates sort of an interesting dynamic in this space where there was a lot of excitement, where there's also a lot of anti-excitement and concern about a lot of things happening in IoT, which we'll talk about today. But the positive part we'll get to is to talk about IoT tomorrow, because while we are, I think, coming off of the peak of inflated expectations, you can see on the horizon the opportunities and the real problems that people are solving and the real ways that companies are creating value in IoT, and that's really what I want to talk about today. So first, a little bit of an introduction on what Particle does. So to give you a sense of where I'm coming from, the easiest way to think about Particle is we help companies connect their products to the internet. So our customers are generally manufacturers of physical products who are often companies that have been around for decades and know how to make physical products. But once you say, I want to connect this to the internet, well, now I'm experiencing a whole bunch of software connectivity, security, challenges that I've never experienced before, so how do I deal with that? So we provide a technology platform that companies can use to connect their products, and it's very widely used. We have 150,000 developers at 8,500 companies using Particle for development. In order to help those companies, we provide what we call an all-in-one IoT platform, which essentially means we extend between hardware and software, and we kind of cross that chasm. We provide cloud-connected microcontrollers with Wi-Fi and cellular modems that are put inside the product. Those run what's called our device OS, which adds support to connect to a cloud platform. We include connectivity, networking, SIM cards, data plans, everything like that, a device cloud the devices connect to, and SDKs for building the mobile and web apps that customers are going to use to interact with these products. So essentially, everything a company needs to take a physical product and connect it to the internet, we provide as part of our platform. You might be familiar with our development kits, which are most people's first interaction with Particle is by buying one of our dev kits to build a prototype of an IoT product. We started with the Spark Core back in 2013. Currently, our customers use the Photon for Wi-Fi and the Electron for cellular connected products. And we recently announced and are shipping in a couple months Particle Mesh, which is the Argon for Wi-Fi, the Boron for cellular, and the Xenon for mesh network products, where every device includes a mesh networking chip so they can all create local point-to-point networks and relay messages back to the cloud. Some of our customers. So, okay, we make some tech. Well, what does that actually mean? What do people do with it? One of our customers is JACUZZI, the manufacturer of hot tubs. So I'll talk a little bit more about what they're doing with their hot tubs a bit later, but basically we designed and manufactured for them a connectivity solution that goes inside the hot tub that connects the motor control system of the tub back to the cloud so they can control it remotely. Customers control it remotely, and their dealers and installers can do remote diagnostics to figure out when there's something wrong with the hot tub. Another interesting customer, a company called OPTI that does stormwater management. As weather becomes more extreme, flooding is becoming more frequent as rainstorms are larger. And if you're a city that built a sewer system, you probably didn't expect that when you built it. So the system can't handle it, which means flooding, which means roads and other kinds of other infrastructure is destroyed. OPTI is a company that connects a control system into the pumps that control the flow of water, the pumps and valves that control the flow of water through the stormwater system, that allow them to do so in a more to control that water in a more intelligent way by predicting weather and using that to inform the flow of water. So if there's going to be a flash flood tomorrow, and you might have a reservoir that would overflow, they'll start emptying out the reservoir in advance of the rainfall so that it fills back up instead of overflowing. And a third customer is if you followed the scooter craze in, I don't know if, has this hit Pittsburgh yet? Are there scooters here yet? They're coming. So in places like San Francisco, the city has been overtaken by scooters that are on the sidewalks and available for use for as low cost as $1. And it started to change how people commute around the city. It's also in some cases a nuisance as they're left strewn all over the place. But it's a really interesting transformation of San Francisco and other cities. And we have customers that are deploying those scooters, and we're of course connecting them back to the cloud so they can activate and activate them remotely and figure out what the battery levels are, things like that. So the position that we're in the industry gives us this really interesting visibility in terms of what's happening, because we have 150,000 people using the platform. They're building every which kind of thing. And we have the opportunity to basically go out to the market and say, hey, everybody, here's some dev kits. Go build something cool, and then wait 6 months and see what comes back. And so the patterns of what are people building, what problems are people trying to solve, what are they doing in a consumer context, in an industrial context, in a municipal context, we get a really interesting view of the market that gives us some perspectives on what's happening today and how the industry is going to change tomorrow. But before we get there, I want to talk a little bit about history to talk about how we got to where we are today. So in a lot of ways, the Internet of Things is a natural conclusion of Moore's Law from the PC, right? So in the 70s, early 80s, finally it was the case that computers got to be small enough that it was reasonable for somebody to have one on their desk. And so the PC revolution happened over the course of the following 20 years. And through that entire time, semiconductor companies and others are investing in making transistors smaller and cheaper. As they do so, they're trying to make those computers more powerful, consume less power, and smaller, getting into laptops. And eventually that activates a second market, which is once the computers become small enough that you can put them in your pocket, then you get an entire second industry that's created, right? The smartphone industry is sort of a natural outcome of the PC industry, just waiting for time to pass and Moore's Law to take effect, where now the computers are in our pockets, and that creates a whole other set of use cases, which of course we're all familiar with, because I expect everybody here has a smartphone or is at least very familiar with them. Now, same thing happens. We keep trying to make smartphones cheaper and smaller and more powerful, and eventually that technology starts to make it possible to connect everything else. Once the cost of connectivity is approaching zero and the cost of putting compute inside a product approaches zero, then that's when the Internet of Things really takes off. And that's why there's been a lot of excitement about this industry for the last decade or so. Now, that said, while the term Internet of Things is relatively new, the concept goes back to telemetry, which is an idea that's been around for a very long time, back to actually the 1870s. This is a picture of the 1906 earthquake in San Francisco, where there were one of the earliest uses of telemetry was in basically detecting earthquakes and signals being sent around the world. So they were able to see this in Germany. Despite how incredibly long ago it was. Now, of course, that's all analog, right? So if you look back at, like, telemetry was in existence in some capacity through the 1900s, but it was really just these sort of analog signals, right? Because, of course, we didn't have digital computing. And so that it started to transform into a second industry called machine-to-machine, in the 1970s, and really the major difference between telemetry and machine-to-machine is the introduction of compute. So the fact that you have digital systems and you can now have a little computer on the device, not just read some sort of raw sensor data, you can actually process information. And the first big use case for machine-to-machine technology was smart meters. Smart meters are now an incredibly ubiquitous technology. There are tens of millions of them deployed in the US. And is really like the poster child of machine-to-machine. But in that same time, there were a lot of other things being connected. You can look at really common use cases like point of sale. So like anytime somebody's come up to you with a credit card thing, and you swipe your credit card, the waiter's holding a thing, that's machine-to-machine. You also have things like tracking trucks and 18-wheelers are really common use cases for machine-to-machine. And that became, the transition from machine-to-machine to Internet of Things came when we started making things IP addressable. So rather than just having just connections of some kind, being able to say this is actually on the internet. The same internet that we use for other stuff is now where you get to the term Internet of Things. The first internet connected appliance I just discovered while I was doing this research was at CMU. So is this still around somewhere?
I don't think so.
I'm not 100% sure. As I was researching this and trying to find the picture of the Coke machine at CMU that was the first connected appliance, I don't know if this is actually it. It felt like it was stock photography that a whole bunch of people have used as the example of it. But regardless, the first internet connected appliance was a Coke machine in CMU that people could remotely trigger a Coke to be dropped from the Coke machine, which feels not that useful because don't you want to be at the Coke machine when you get a Coke out of the Coke machine? But regardless, this is the first example, and since then, of course, many more examples of machines and appliances that are connected.
It's the robot that takes it.
Right. Well, that's phase one is remotely get the Coke, and then phase two is the robot. Right. So. So although it's a new industry, although some of the dynamics that have caused it to be sort of this large and interesting growing industry are new, it's really at the same time the result of more than 100 years of development of being able to essentially look at and control things remotely. So to summarize, we have two different directions sort of coming together, right? Which is smartphone technology now becoming cheap and ubiquitous so that everything can in theory have compute and be connected, while simultaneously sensors are being deployed all over the place, and then that's IoT. So okay, that's a little bit of history about how we got to where we are. So what's happening today? Well, the first thing to talk about is that everybody means something different when they're talking about IoT Internet of Things. There are a lot of different sub-industries that we sort of group together and classify as this broader industry. So it's, at least before we get into it too much, we should talk about what are the various flavors of IoT that somebody might be referring to. Well, I think the one that we see most often and that is most that we often associate with IoT is smart home, right? So the idea that physical products in our house, in many cases ones that we've had for decades, if not more, are now starting to become internet connected. This really became a popularized thing with the introduction of the Nest Learning Thermostat back in like 2011 or whenever it was launched. And now other big categories, so thermostat, security systems, smart locks, light bulbs, are kind of the major categories that have been taken over, but you do have other examples of refrigerators and sort of white goods and other appliances around the house that are starting to become internet connected. This is a little bit misleading because this is a very visible part of Internet of Things, but I'd wager a guess that it's a very small percentage of the market. It's just the ones that we can all so easily understand. And so we come back to tell stories about smart homes so frequently because we all are human beings that live in homes, and so we can have a conversation about it where some of the other use cases for IoT may feel very esoteric and weird if you're not in this particular industrial environment or whatever it might be. I'd say a second category that falls in that same area is wearables. So wearables really took off because Bluetooth Low Energy was added to all of our phones, and so all of a sudden it was possible to connect things like fitness trackers and watches. And they've had their ups and downs, right? Fitbit became a huge company, IPO'd, very successful, but at the same time their stock price has dropped dramatically since they IPO'd. One of the early successes in this space was Pebble, which launched the largest Kickstarter campaign at the time, and then afterwards one that was twice as large for their second generation product, became incredibly successful as a really out of nowhere startup, and then crashed and burned and sold their assets to Fitbit. And of course now Apple Watch is really the most predominant wearable that you see, combining a lot of health tracking information with sort of notifications, things like that. But an example of wearables represent an example of IoT applied to your body, essentially, right? So all of the various pieces of technology that one could be connecting that fall into this personal area network, typically using Bluetooth to connect to your phone. A third area is set-top boxes. This is funny. This is a funny one to me because I don't typically think of this as being Internet of Things, but basically TVs used to be dumb and now they're smart. And they're smart because we have boxes like TiVos and Rokus that we add to our televisions, and also the TVs themselves now have a lot of this. So if you buy a TV these days, I don't think you can even get one that doesn't have some kind of smart features. And that means that besides the fact that you can download media to it, it also has telematics and remote diagnostics, over-the-air software updates. So there are a lot of things that make it very similar to the rest of the IoT applications. At the same time, it feels a little bit different because it does have a screen, so it feels more like a PC or a smartphone relative to some of these other things that are more about like sensors and interacting with the physical world. But it's classified as part of IoT. You also have things like, I'll do them together, drones and robotics, right? Which are very, drones have a ton of use cases these days. A lot of pictures, videography kind of applications, but also a bunch of sort of sensors flying over farms and buildings to track what's happening in construction sites, things like that. Of course, robotics, which is also a field that's been around forever, that predates IoT, but is often lumped into IoT because it falls into that same category of, okay, we've got computers and sensors and actuators all doing a thing together, so I guess we'll call that the Internet of Things. Factory automation. Factory automation is an interesting world because we've been doing factory automation, again, for decades, mostly with locally connected systems where the machines are trying to talk to one another for some specific purpose or get information back to some kind of control center within the room. And so historically, not necessarily internet connected, but some kind of wired connections, a local network to create this. And you have systems like sort of SCADA systems and a variety of different ways that these machines communicate to one another. Now, the companies that operate these factories and that create this equipment are trying to layer on additional software to these old-fashioned systems that were really single purpose at the time. And so you have this whole mess of a world where, like, I've got 100 different machines in my factory and they're all speaking a different language all over different kinds of wiring. And I want to somehow collect all this information in one place so I can run an analysis or do something with it. And that's a whole mess of data analytics that's still being solved. Newfangled telemetry, which basically is to say, like, it is still the case that the most common use for IoT is remotely sensing something that is far away. And in a lot of ways, that's not that different from monitoring earthquakes in 1906, but now we're doing it with computers. And so there are more powerful things that we can do. There are more complex things that we can do. But at the end of the day, it's really just the evolution of that same basic concept. You also have an introduction of new business models as a result of connectivity, which there isn't really a term of art yet to cover, but I call it hardware as a service, which is basically to say you can now sell physical products not by actually selling somebody the physical product, but by giving them the physical product and charging them for the use of it. So the most famous example of this is GE's jet engines. Once upon a time, if you bought a jet engine, you bought a jet engine, and you owned a jet engine, and that's good in that you have ownership over it, but it's bad because you have to spend a whole bunch of money up front. And if the jet engine breaks, it's your problem. And so GE transformed their business model around jet engines by saying, well, what we're going to do is instrument the hell out of them, and then we're not going to charge you for the jet engine, we're going to charge you for uptime, which is to say, how long the plane is in the air, right? Because their perspective is when the plane's not in the air, it's our fault because the jet engine broke. And so if we can monitor it and fix it and then provide uptime as a service, which is really the value that the airline gets from it, they don't get the value isn't the jet engine, the value is it makes the plane fly. And so they're charging them for the plane flying. Which is a totally different business model and something that's starting to become more common where people start to say, well, rather than thinking about the physical unit, what is the value that the customer gets from this physical unit, and can I monetize that value instead of the asset itself? So that's a little bit of an overview of the of what is in IoT. Now to talk about the state of the industry, there are a bunch of problems that we're working on to try and make these products work. And it's a totally different set of problems, again, depending on who you ask. So first problem, there are not a lot of skills out there to build IoT products. And so this is an interesting one because in theory there should be. There's a lot of people who know how to build internet stuff, i.e. software engineers, and there's a lot of people who know how to build physical stuff, i.e. embedded systems, electrical engineers, mechanical engineers, so on and so forth. And so you'd imagine that you take a bunch of these people and you take a bunch of these people and you smush them together and you now have an IoT team. And in practice, that is what a successful IoT team looks like, but it can be really difficult to actually get that to work because these two groups of people have been operating separately for decades and have developed completely different ways of working and completely different cadences of working. So you see this in particular in that software development has become more and more agile. The ways that people build software is very iterative. They try and push releases every week or every day, and so and if you break it, who cares, because you can just fix it in the next release. Whereas with hardware, you can't take that approach, right? The product that you ship to the customer is going to be there for 10 years, and so you can't screw up anything. And so you have a totally different way of designing that product, which is a waterfall methodology, which means that you have to get everything right when you send it to manufacturing. And now you take this methodology and this one, and you put those two people next to each other, and it all starts to fall apart. Not to mention the fact that there are parts of the stack that are in between where neither this person nor this person really knows how to do that thing, and so getting them to collaborate can be very challenging. So what happens is the companies that make widgets that are the natural sort of owners of IoT often don't know how to make those widgets internet connected. They don't have the right people on their team, and even if they do, if they can grab some people from their IT division and grab some people from their hardware engineering division, they really have a lot of trouble actually getting that to work so that they can get one of these products to market. Not helping is the fact that there's a lack of tools. So I pulled this is probably too small for anybody to see, but it's a little code snippet that I pulled from the Arduino documentation, which is about how you would have, which is just a few lines of code where you would have a device connect to Google and get some information from Google. And the reason I use this example is that when people are building IoT products, they often have to go all the way to the bottom and do the shitty work that has been abstracted for us for decades in software development, where you actually have to open up TCP sockets and do this stuff that you shouldn't have to know anything about how that works. You have to go all the way down into the networking stack, and there are not enough good tools that make it easier for somebody to build one of these products, which is of course a problem that Particle's working on, but there are unfortunately too few solutions out there. There's also a lack of standards. When you get into the technology that people use, with the web, we've gotten really comfortable with the fact that there's this thing called HTTP. It's how the entire web works. Everybody agrees on that. Every web client on your computer, your Chrome, Internet Explorer, Firefox, Safari, whatever, they all know how to talk to all of the websites. Right? There's this standardization of technology. That's an incredible thing that that's the case. And we're not there yet with IoT. Devices can't talk to each other. Devices can't talk to the same servers. People use different technologies in different places. And there's reasons for that. It's a very fragmented market. But the technology is not standardized, which makes it hard to figure out what to do when you actually get going trying to build a product like this. There's a whole bunch of security problems. This is a picture of the centrifuges in Iran in their nuclear facilities. So who's familiar with Stuxnet? So I won't go into the weeds too much on this, but it is worth a read if you want to understand how we basically slowed down the nuclear program in Iran by speeding up their centrifuges just a little bit so that they basically misbehaved by introducing a worm called Stuxnet that basically made all of their systems incredibly unreliable. And it's an incredible IoT hack because fundamentally what we were doing was disrupting somebody else's physical infrastructure. Now that's going to become more and more common. And in this case, we were doing this to disrupt a nuclear program, so you can look at it as like, the good guys, solving a world crisis. But there are definitely cases, and going to be more and more cases, where it's going to be the bad guys attacking the good guys and their infrastructure, right? So you can decide on your own who the bad guys and the good guys are in this equation. But the more and more our infrastructure is connected, the more and more problems there may be if that is not well secured, where you get bad actors, in some cases geopolitical bad actors, trying to disrupt one another through IoT hacks. We have interoperability problems. So different products don't really work with each other all that well. One of the obvious cases for this is voice control in the smart home. So if you have, raise your hand if you have some kind of voice control system in your house. Okay, decent number. Alexa, Google Home, what do we got? I see nods on Alexa. Both? You got a whole bunch of different things in your house, and now you want to control them with your voice. So this feels like a big win, right? And voice control is a great way to interact with IoT products. It really reduces the friction to interacting with these products. However, there's a big interoperability problem. A lot of the products don't work with these voice control systems. The voice control systems don't work with each other. Getting them all set up and working together is hard. The glue between all of these products hasn't really been created in many cases. And so in a lot of cases, the ways that we interact with these products by getting these systems to work together are hacks that somebody's figured out. You Google a thing and you're sort of reading these detailed technical instructions on how to get this stuff to all work together because somebody's hacked their way around a system because poor security, which the upside of poor security is it means you can make systems that weren't designed to work together by hacking them. But not an intended behavior. And the result is consumers, none of this stuff works together and it's all really annoying and the setup process sucks and is it even worth it to begin with? We also have a problem of stupid products. Does anybody work for Wilson? No? Okay, good. I use this example a lot and I'm worried that one day somebody from Wilson will be in the audience. This is a stupid product. It's a basketball that is internet connected. Why do we need our basketballs to be internet connected? Because it will count how many shots you hit or miss, which of course you could count yourself. So okay, maybe that's moderately useful, but it's $300. I don't think they put it on sale because I don't think anybody was buying it at $300. It was $300. It also has a dead spot because it has a Bluetooth chip inside it. And so there's some place where if you bounce the basketball, it won't bounce back because there's a chip, there's a little chip on the inside. So it just sort of thuds when it hits the ground. So it's a bad basketball that costs $300. And there's unfortunately too much of this. And it draws a lot of attention. It draws a lot of media attention. So you get a lot more stories in the media about products like this than you do about the actually interesting things that solve real problems. And you also have orphaned products. So you have a problem where companies that build IoT products deliver them to customers and then go out of business. And when they go out of business, they leave behind these orphans. And then there's a question of what happens to the orphans. In most cases, they're shut down. A very visible example of this was Revolve, which was a smart home hub system that was kind of clever. It could hook together a bunch of different IoT products to try and create a seamless experience. It was all based on hacks, so again, poor security was the only reason this product worked. They were bought by Nest, which was owned by Google, who has large piles of money, right? So you would hope that they would provide some ongoing support to the people who had already paid a couple $100s for this thing. They did not. The product was shut down. There were a lot of jokes about how what you were left with was an upside down hummus thing because that's what it looks like. Because once some products, some IoT products, when you eliminate the internet connection, still do something. Like if you have an internet connected coffee maker and the internet connection goes away, one hopes it still makes coffee. But this was a hub, so it does literally nothing after you drop the internet connection. So maybe you can put hummus in it. But the real problem is that most companies don't really know why they're connecting things. And this is the sort of crux of where we are in this industry, is that there's ubiquitous knowledge that the Internet of Things is a good idea and that it will transform your business, and then having an internet-connected product is better than not having an internet-connected product. However, what that translates to in practice for any company that actually wants to go build one of these things, there's often a miss, right? Where you add the internet connection and then hope that the opportunity will make itself clear once you've done so, rather than thinking up front, what is the actual problem that I'm trying to solve here? What's the reason for adding connectivity to this product? So now, I'm going to get off all the negative and talk positive for a second. All that said, there are some really good examples of IoT done right, which fundamentally start with a clear problem that somebody is trying to solve. So, coming back to the stories I told at the beginning of some of our customers, I want to talk about the problems they're solving. Raise your hand if you own a hot tub. You own a hot tub. Thank you. You're my guinea pig now.
I used to live in California.
How do you like owning a hot tub?
Well, I like a hot tub.
What is the worst part of owning a hot tub?
Knowing that my chemicals need to be boosted.
Right. So managing the chemicals in a hot tub can be challenging. They fluctuate a lot, and of course, it's a very hot environment. You want to make sure you get the chemicals right, because otherwise, who knows what's floating around in there. They also can be really challenging to maintain because they're big, wet machines that you leave outside. So they break a lot, and so they become a maintenance burden. So JACUZZI, one of our customers, when they think about why they're doing IoT, the story they told us is, look, a hot tub is supposed to be a luxury experience. It's supposed to be the kind of thing where when you go buy it, you now have a spa, you now get to relax, and you're supposed to have a glass of wine and listen to some music and enjoy your hot tub. But practically speaking, a lot of times ownership of a hot tub is like owning a boat. You know, you bought a thing that you now have to maintain, that you're going to sink a bunch of money and time into, and so it can be a very unrelaxing experience as a result. And so the problem they're trying to solve is, how do they eliminate or reduce the maintenance burden of having a hot tub? A lot of it comes down to the chemicals and making it easier, or even eliminating the need for customers to sort of manage the chemicals themselves. But you know, as adding to that all the other maintenance challenges that can be created, and also addressing the energy costs, because a hot tub is a big consumer of energy, which means it's the kind of thing that you actually see on your energy bill, as opposed to, you know, a lot of things, lights, for instance. Now that you have LED connected lights, there's very little value in reducing energy off of an LED light, because the fact that you made it an LED light means it consumes so little energy that it doesn't matter anymore. But this does actually matter. So, but fundamentally, solving the problem of maintenance, because that is the downside of owning one of these products. OPTI, you know, we talked about this use case a little bit at the beginning, but you can see where the real problem is here, right? If you're a city and you have to deal with the weather, and you have to deal with the impact on your infrastructure. Cities around the country and around the world are struggling to make ends meet, fundamentally, right? In a lot of cases, their budgets are very limited, and you see this with investments in public transit being difficult to actually make those investments. You see it in a lot of places where you know, the roads are starting to deteriorate, and there's not enough money in the budget to fix those roads. So if you're a city in this position and you've got this problem with flooding, so you have two choices, right? Am I going to spend a whole bunch of money up front to improve my stormwater system so that I can actually deal with the water, which will then decrease the ongoing cost of maintaining the roads because there will be less flooding? Or am I just going to let the roads deteriorate and then keep fixing them more frequently? Purely financially, you should do the former, because it's a good investment over time. But if you don't have the money, it really doesn't matter. You can't do the former, so you have to do the latter. So we just are spending a ton of money replacing roads that don't have to be deteriorating as quickly as they are. So, okay, you don't have the budget, you don't want to deal with the ongoing cost. Well, a solution like this is a really affordable way to fix this problem, because rather than saying I need to fix my stormwater infrastructure, you just say, I can improve my stormwater infrastructure by using it more intelligently. And I don't actually know what OPTI charges for these things, but I assume that relative to the cost of rebuilding sewers, it's probably pretty affordable. And it gets them a long way towards solving the fundamental problem. Last year, when the hurricanes hit Florida, there was one city in Central Florida that was that managed the water really well because they had OPTI installed, and so they were able to, on the fly, as the path of the hurricane shifted, they were able to move water around before the storm happened, so that they were better prepared when it hit. And scooters is an interesting one because it's been in the news a bunch as a nuisance, but it actually does solve a real problem, which is a problem of traffic. So Lyft and Uber have really changed how people get around in cities. Definitely the case in San Francisco. I expect the case here. But in San Francisco, for instance, I mean, the largest taxi company went out of business maybe a year and a half ago because taxi rides were down 60%. Now, in San Francisco, yeah, there were taxis before, but you couldn't actually ever find one. So it sort of didn't matter that they existed, that you couldn't just like walk outside and raise your hand like if you're in somewhere like New York. So Uber and Lyft really changed how people got around, and it made the city much more effective as somebody who lives in the city. Now, that said, it also makes traffic worse because you're adding cars to the road. And no amount of drivers solves the problem of rush hour traffic. So in San Francisco, when you've got a Giants game, the whole SoMa and the whole city shut down and you can't get around anymore. And that problem can't be solved without taking cars off the road. The reason that scooters are interesting is because they become the most compelling solution to get around short distances when there's traffic, right? So if there's not traffic, it's cheaper than a car, but you might decide to do one or the other. But when there is traffic, the roads become unusable as a car, but they're still usable on a scooter or a bike. And so the existence of these products makes everything work better. It makes the ride-sharing platforms more effective. It makes driving a car more effective because it takes drivers off the road. Not to mention the fact that these are electric, so that's a positive impact on energy consumption, on carbon emissions, things of that nature, right? So it's an environmental solution. And yes, there's still things that they're working out about the fact that people are assholes and they leave them in the middle of the sidewalk and then other people trip over them and that sucks. But relative to the real problem that it's solving, that's why these guys are getting so much investment, why they're raising so much money, is that there is actually a real problem here that they're solving. Okay, so that's today. Let's talk about tomorrow. So thinking about what's coming down the road in IoT, it's a little bit of a mixed bag. There are some bad things that exist today that I expect will continue, and there are some good things coming around the pipe to be excited about. So fundamentally, I think things will probably get worse before they get better. Again, coming back to where we are in the hype cycle, we're still on our way down. So we'll start with the worst, and then we'll come back to what's going to get better. So security breaches, we talked about a little bit, but they'll probably get worse. Another example of an IoT security breach, which is not always known to, not always realized to be an IoT security breach, is Target. So I expect everybody remembers a couple years ago that Target had a huge hack into their point of sale system, which means that credit card information was stolen. Probably all of our credit card information was, everyone here probably had some information stolen in that breach. Now, you may or may not know the story of how that breach happened, but the breach happened through the HVAC system. So basically, they had connected HVAC systems in the Target stores that allowed the people who oversee the store to be able to control the HVAC. An engineer who worked at the HVAC solution provider was socially engineered, which is to say they got his password by convincing him that they were somebody who should have had his password. I'm not exactly sure what the story is. They got access to the HVAC system, which was locally networked on the same network that the point of sale systems were on. They used that to find a backdoor into the point of sale systems, install a worm that was distributed. They found their way to a point of sale system administrative system that could then push out a software update to all of the point of sale systems in all of the stores. And that's how they got access to all of our credit card information. So this is often the case with IoT. Sometimes IoT security breaches are actually hacking internet-connected systems to disrupt those systems, but in many cases, they're hacks to insecure IoT systems as a way to get into something else, right? Another example of that is the Mirai botnet, which a year and a half ago, people used webcams to attack Dyn, a big DNS provider. So the internet was a lot of the internet was essentially taken down for about 6 hours. Later, they attacked the internet of Liberia, and the entire internet of Liberia was taken down for a day or two. And so these breaches are likely to get worse before they get better, because these insecure products are still out there. It is the case that today, when people go build an IoT product in 2018, there's usually enough smart people around the table that are advising them to invest in security that more often than not, those products are secured. But all of these insecure products that are already out there aren't going anywhere. They're not being taken off. They're not being taken down. Those webcams are still in people's homes. And so these breaches will probably get worse as hackers start to realize the opportunities available to them by hacking these systems. And so you're going to see more stories about security issues, which will continue to cause concern for a while. Also, these intercompatibility issues will probably persist. This is something that's very frustrating as a consumer, because you really want all of these products to work together. But the reason they don't is because all these companies are jockeying for the position of being your primary point of entry into these IoT products, and nobody's willing to concede it to anybody else. So although we as consumers wish they would all play nice, they don't have any incentive to play nice. They're trying to win. And one day somebody will probably win, and other parties will have to coalesce around them. But in the meantime, it's not clear that that's going to happen anytime soon. And so these issues are likely to continue for some time. Okay, that's the negative stuff. Let's talk about the positive stuff. Moore's Law is going to keep on trucking, right? So connectivity and compute are starting to become cheap enough that you can now put them in a whole bunch of different products. But the prices on the kinds of things that are necessary for IoT keep getting slashed very significantly. Adding a cellular connection to a product this year costs half as much as it did last year and a quarter of what it did 3 years ago. I mean, the pricing is totally different than it was, and that's likely to continue. So as that happens, there are more and more IoT products that go from being sort of unviable commercially, they don't make any economic sense, to starting to make sense. And this pattern will continue. So when we talk to customers about what their IoT plans are, we advise them to think about the cost structure going forward, not necessarily the cost structure today, because it's going to take a year and a half to get a product out, and a year and a half from now, the economics are going to look different. LPWAN is kind of a mess right now, and it will probably get figured out within the next couple of years. LPWAN stands for Low Power Wide Area Network. It's basically a whole bunch of people who are trying to figure out how to get something that looks like a cellular network, which is to say it's everywhere, but supports low power, low bandwidth devices, because cellular networks are still, in many cases, too expensive for IoT products, and it consumes too much power to try and send a message to them, because they're really designed around high bandwidth applications. They're not really suited for IoT in many cases. So there's a bunch of different companies trying to solve this. Sigfox, LoRa is an open standard, and the carriers have their own thing called narrowband IoT or NB-IoT. These are all technologies that are relatively new. They're sort of fighting head to head to provide a solution in this space. My money is on narrowband IoT, the thing that the carriers are doing, which is likely to get deployed over the next couple of years. Although I think LoRa is really good for private networks. So if I had like a hospital and I wanted to connect a whole bunch of stuff in the hospital and I could deploy my own network in that hospital, LoRa is really good for that. So it's likely that over the next couple of years there will be ubiquitous low power, low cost wireless networks that don't exist today. And that will, again, make it so that things that are not possible today become possible. The skill gap will close. So it's frustrating how few companies are able to build an IoT product today, but if you look at what's happened with software development, a similar pattern is likely to emerge. I mean, these days there are, forecasted to be 26 million software developers in the world in 2019. And I was looking for numbers as I was doing this that sort of go back to like 70s and 80s when software development was a brand new field, to say what is, what was the growth like over a 30 or 40-year period. Unfortunately, I couldn't find any data on that growth, but you can assume, well, at some point it was 0, and now it's 26 million. Although it is currently the case that there are too few people who know how to do this, of course, people are learning every day. There are programs being set up to teach people skills in IoT, like this one, and more engineers who either know the physical side and are getting into software, or who know software and are getting into the electrical and mechanical side. So the skill gap is going to close over time. And the last interesting sort of future prediction is about how the future of AI and IoT are linked together. So this is a book called Prediction Machines, with a really interesting idea that talks about the economics of AI and fundamentally how complementary technologies work together. So basically the idea is, as one technology becomes cheap, all of the other technologies around it become very valuable. And so you see this in the case of transistors, right? So the cost of transistors that's Moore's law. The cost of transistors comes down and down and down and down and down. And as that happened, the value of other neighboring components, power management systems, batteries, increases, because now all of a sudden there's new uses for those technologies being activated by the sort of commoditization of this technology. And the argument that the author Ajay Agarwal makes in this book is that AI is on that kind of commoditization slope where the cost of AI is going to drop massively over the course of the next few years. And AI and IoT are complementary technologies because basically, if you want to predict something, what you need is data to fuel the prediction algorithm, and then some ability to use the prediction to influence some outcome, right? So you basically have the input, the prediction, and the output. The inputs, in many cases, are sensors. And the outputs, in many cases, are control systems and actuators. So if you look at something like the Nest Learning Thermostat as an example, a thermostat has both sensors and control systems incorporated. And so if you can suck up all of the data from all of these houses to better inform an algorithm to figure out when you need to turn the HVAC system on and off, and you can use that to better influence the HVAC system, as the cost of AI decreases, the value you can deliver through that algorithm increases. And so the investment you want to make in sensors and actuators increases. So basically, all that is to say, IoT is going to increase in importance as the ability to make effective predictions with the data we get out of these devices becomes more effective. And finally, the winners are going to be the ones solving the biggest problems. So, we're good. IoT is a huge industry that really covers 75 different industries underneath it. And so if you want to think about like which companies are going to win in the long term, I pulled this. This information is about smart power meters and their growth over time. So currently, half of electric meters are smart. They have smart meter systems installed. It means that everybody who's involved in the smart meter industry is winning. The companies who manufacture them have made incredible businesses. The electric companies that are deploying them are able to be much more intelligent about how they move around energy. And so everybody in this space is winning because the problem is massive, right? The inefficiencies in our energy infrastructure are very significant, and having information about how people consume energy all the way at the end is really valuable to reduce that inefficiency. So big problem, big winners, right? And so I think that will affect so when you think about IoT and where you want to make investments, the important point here is to try and solve the biggest problem that you can. So, in conclusion, IoT has been a very hyped industry for a decade. Ignore the hype. At the same time, ignore the anti-hype, right? As we start to fall off the top of the Gartner hype cycle, the negativity around IoT also worth ignoring. The most important thing to do is find a problem we're solving and solve that problem. So, any questions? Yeah.
You started off by saying the visible part of IoT is the smart home, right? Where it's tangible when you think about it, right? And I do a lot of work on IoT, and whenever I talk about it, my motivation is very much like that. You hear about it, you hear we'll have 50 billion devices, but where are they? Because often some of it is we don't see them, but they're definitely not in our home.
Right.
So what do you think is, if you're thinking verticals, if you're thinking about actual domain where they will have the biggest financial impact, what do you think of? So you as a platform developer,
right?
You may have a much better view at this than people who are solving point solutions. So what do you think is the...
So it's a tough question to answer, and you framed it in financial value, which is a really important, I think, distinction, because in a lot of cases, the way that people measure the size of IoT is about the number of devices, the number of units. And so if you go dig under one of the Gartner analysts reports that says, here's how many IoT devices there are going to be at some point in the future, the two biggest categories are smart grid and TVs. TVs. Yeah, smart set-top boxes. Because basically, we all have one of each, right? So the fastest way to get to a large number of units is to deploy something that every single person has and get to ubiquity. So we all have a television, and we all have an energy meter, and 50% of the energy meters are smart, and probably at this point, 100% of the new TVs being sold are smart, but if you look at TVs in homes, it's probably something like 50%, because people replace TVs relatively frequently. So those are the two biggest unit numbers. Now, that's frustrating when you think of like, okay, well, what about the value being created? Because there is real value being created with the smart grid systems, but with TVs, it's sort of like, I guess so, but it doesn't feel like the answer to your question, right? Of like, where's the financial opportunity? At the same time, if you look at companies that manufacture really heavy equipment, so like GE, the jet engines, right? They're creating extraordinary financial value for every jet engine that they connect. However, I don't actually know how many jet engines they manufacture, but it's probably not that many, right? Because it's an extremely expensive, relatively low volume product. And so when we think about the scale of an opportunity, so when we have customer come to us and we're trying to decide, excuse me, are they really serious about this? Is this somebody, like, are they actually going to invest in this initiative? Is this someone we want to invest our time with? We're thinking about the scale of their problem. In a lot of cases, the first thing we do is try and measure the size of their fleet, and we do that by dollars. So basically, how many units do you have times how much are their units worth? So if you have 100 machines that are $1 million each, it's a $100 million fleet. If you have 1 million machines that are $100 each, it's a $100 million fleet. And the value of the fleet is a good proxy for how big of an opportunity there is there. But you sort of have to incorporate that like volume and value. Now there are cases where people can create unbelievable value with like really cheap things. So you see this in like water filtration plants where historically they had very poor visibility into the state of the water going through the filtration plant, and you add a couple sensors which cost almost nothing, and you now have an intelligent plant, and you've created a ton of value with a really small cost. So those kinds of applications tend to be the ones where there's the most dollar value. Just sort of big, expensive systems that haven't been connected yet.
So I can follow up.
Yeah.
What you did say was interesting, right? Because you hear people talk about healthcare, they talk about smart buildings, they talk about, so some of these are like if you think about from a dollar value, the $1 trillion opportunities. I think healthcare is a disaster right now in terms of like inefficiencies and what you could do. But why not any of these? Like, why do you think? Because at many points you say, oh, IoT is poised to sort of upend how we do healthcare, how we might do sort of elder care. Look, lots of different applications, but you didn't say any of them. You picked TVs and sorry, what was the other one?
Smart grid. Yeah.
In a funky way, there's only like one per household typically.
Right.
So the numbers you hear are like 50 million or 50 billion or 100 billion devices by 2025.
Yeah.
That can't be TVs and smart meters. There's only one per household.
So I'll start by saying I think a lot of the numbers are just total garbage. You see this Gartner has reports that say that the value of the IoT industry in 2020 is $7 trillion. To put that in perspective, the global economy is $77 trillion. So it's 1/10 of the global economy, like 2 years from now.
Yeah, no.
Feels unrealistic, right? Now, I do think that if you sort of zoom out and say, over some period of time, if IoT will be adopted anytime that anybody is manufacturing or using or moving any physical product, yes, it's reasonable to say this will be a multi-trillion-dollar industry, but not on that time frame. So take all of the big numbers and like push them out, and I think it starts to be more realistic. But I think to come back to your point about healthcare and smart buildings. So what I see is a really common pattern is you have these huge problems like healthcare, right? Which is, I mean, we could do a week on healthcare and not even scratch the surface on it, but the healthcare system's a mess. Are there opportunities to solve some of those problems with IoT by essentially trying to get better information on what's happening on the individual patient level back into the system? Yes, absolutely. However, it's one of those problems where like there's this big thing that you can theoretically get to out there, but then when you actually look at like smaller problems, they don't necessarily tie to like the bigger problem down the road. So we have a customer who does CPAP machines, sleep apnea masks that you wear when you're sleeping to help you breathe, and they're using connectivity to basically ensure compliance, because the issue, CPAP machines are very effective if you have sleep apnea, but a lot of people don't use them because they're uncomfortable and they're big and they make you look like a fighter pilot. So like there's a bunch of reasons they don't get used. So they want to be able to ensure and guarantee compliance, because insurance companies don't want to pay for a product that isn't used, right? So they can say, look, we'll show you the data on how these things are actually used so that you will continue to pay for these so that we can still keep giving them to people, right? So that's a very specific problem that can be solved today. But it doesn't really help us close the gap towards like solving healthcare. And so that problem of solving healthcare still ends up being very far away. Whereas you see cases like, we have a customer that does HVAC, where they're trying to improve service and maintenance on air conditioners. What they really want to do is predictive maintenance, is to say, these machines are out in people's homes for 10 years, and I want to be able to predict failure before it happens. But I can't predict that failure today because I don't have enough data. So the first thing I'm going to do is I'm going to connect sensors to these air conditioners, and I'm just going to do break fix, which is to say, the moment it breaks, somebody will be informed and they'll go out to fix it quickly. That is a piece of value. That's a thing we can do to solve a problem today that's very real. And it also is the first step towards the longer term problem, because once I have 10,000 of these things out there, then I can start to collect enough data to inform a prediction algorithm. And so having that long-term opportunity, it's hard to figure out how you tackle the big opportunity if there's not a first step that creates value today that moves you in that direction. And so the reason I didn't talk about healthcare and buildings is I think those are two areas where there's a little bit of that problem of like huge opportunity, hard to figure out how to go about it, if that makes sense. Other questions?
How do you feel about the Web of Things, the initiatives from W3C? They're like we're building systems of systems and they need to interoperate.
So there have been a bunch of different initiatives to try and create intercompatibility between devices. All of them have failed to get adoption. And it sort of feels like, if anybody reads the webcomic XKCD, there was one where it's like, there are 15 protocols out there. What we really need is one protocol to solve them all. So I'm going to create that. Now there's 16 protocols out there, right? And so there's sort of this problem where there are a bunch of different available options that in theory, if everybody coalesced around, would create interoperability between these products. But nobody is coalescing around them. And what keeps happening is just somebody comes up with a new one every 6 months. And a whole bunch of companies stick their logos on them, which also makes it seem like there's adoption, but all they did was just get some PR person from these companies to say, yeah, I'll put my logo on it, that's fine. And so there's just a big adoption gap. I think that adoption gap comes from the fact that we as consumers want interoperability, but the companies don't actually want it themselves. So when they go to invest in a product and say, what technologies am I going to put in this product? How am I going to build it? What communication protocols am I going to use? What standards do I use? Do I choose to use the open ones that are, in theory, will create interoperability? Nah. I kind of like them, but they don't quite solve my problem, so I'm just going to do my own thing instead. And this just happens over and over and over again. I think the real solution to interoperability is going to happen at the cloud level, because we do have a standard way of talking web service to web service, which is HTTP requests. So if you have, the way our infrastructure works, and the way that these days most IoT companies' infrastructure works is my devices are all talking to a set of servers. And that's really all of my internal, how this thing works, is that client-server relationship between all my devices and this small set of servers. Now I can have my servers talk to other web services using the language of the web, and now we can also deal with security issues like authentication. I don't want my devices just talking to other devices on the local network in an unsecured way. I didn't give them permission to do that. What I want is to say, if this thing wants to talk to this thing, I want an authentication request, the same way that we authenticate with like Facebook and Twitter with OAuth, where we as the users of these products says, this app wants to post on your wall. Do you want to allow it to post to your wall? Yes or no. And that's really how IoT should work, is this voice control system wants to control your lights. Will you allow it to do so? Yes or no? But we haven't really gotten there yet. That's not really the design pattern that people are using. They're mostly just hacking into each other's insecure systems. So fundamentally, it is possible to solve the interoperability problem, but it feels like we're a ways away. And the open initiatives have not been successful.
So for something like that, this cloud level thing, right, which is right now it's all vertical stovepipe, right? It's like Nest has its own cloud.
Yep.
And then you have somebody sitting like IFTTT or Zygley or one of them sort of saying, we can be the glue that connects together with our services. The fundamental problem with that eventually turns out to be sort of disconnected operation. But we cannot, as you just pointed out, if my smart lock stops working because it really needed a connection to the cloud to authenticate me and I can't get into my home, that'd be a disaster. So in theory you're right, that having these sort of integrated cloud within every device manufacturer can be like, we will build our cloud and give you a REST API.
Right.
But it sort of misses this major problem of how do I get this authenticated, secure, sort of local access, even if my network connection is etc.
So I think that totally, and this is where the design of a good IoT product assumes a fragile connection to the cloud. Because we're not using copper wires, right? If you have when you build a robot and you have a bunch of sensors all talking to some computer in the robot, and they're all hooked together with copper, you can pretty confidently say these sensors will all be able to talk to this computer so long as somebody doesn't chop the robot's head off, right? Now we move into wireless, and as soon as you go wireless, you have to assume that your connection is unstable, and so when you design it, you have to factor that in. So for instance, I'm just about to buy a smart lock. I'm very excited because somebody finally designed one that I think is designed correctly, which is the Nest and Yale did a collaboration to build a smart lock, and it's a touchpad, so you don't actually open it remotely. I mean, you can open it from your phone, but you really set the code from your phone and then use the code to let yourself in. And so then you can distribute out keys and you can make them one-time use and all those kinds of things. But it drops the logic of that into the lock itself. So if the connection dies later, it's not an issue. And then the really smart thing they did is say, well, what if the lock loses power, right? This is the problem, is you have to carry your keys anyway, because if the lock loses its battery, then you don't want to be stuck outside. So there's a little place you can jam a 9-volt battery that will just power the system up enough to allow you in once, right? And so you can leave a 9-volt battery in one of those little rocks in your yard or whatever, and that's way better than leaving a key in that lock, because if somebody finds the key, they can get into your house. If somebody finds the 9-volt, they still don't have your code, right? And so it's sort of intelligently designed, where they've taken all the layers of what information needs to happen in the device, what needs to happen in the cloud, how you deal with power management. And they've done it correctly so that in every edge case, it still makes sense. And that is, I think, one of the big challenges of design of an IoT product is we've been building smart locks for at least a half a decade now, And only now at least in my perspective, is there a product that was actually designed correctly, right? So in a lot of cases, we're still iterating our way towards the correct design of that product. But I do think fundamentally, as it relates to the networking, you always have to assume that the connection might go down, and the product still has to work to some capacity when that's the case.
We might leave it there because we're going to switch over for the next panel. But let's thank Zach for the.
I'll be around if you have any questions, and also if anybody is, just one quick shout out is if you're looking for a job, we're hiring, and I've got some little cards on it. I also have my own business card, so if anybody wants to follow up, let me know. Thanks.